Traditional construction process rely on what we call bespoke design. So each project is designed independently, constructed independently. So there is very limited knowledge reuse across different projects. So with productization, we are trying to bring some of the best practices from the manufacturing industries like modularity into construction industry. So what we do is we take a building and break it down into various modules, interchangeable modules, by defining standard interfaces. So this allows us the flexibility of customizing the building based on individual project needs, but at the same time reduce greatly the time to construct, the time to design, and also the wastage for each building. So we are able to maximize the reuse across projects. So productization is actually a direct heritage of Gustav Eiffel, the Eiffel Tower project. So productization has a number of benefits. We look at the capital projects industry, about 80% of the projects are over schedule or over budget, right? So with productization, we are able to reuse knowledge across projects. So this greatly reduces the design and construction time. According to some reports by McKinsey, some projects can save up to 50% of design time by maximizing this reuse. We are also promoting the manufacturing of these modules in off-site factories. So we are greatly increasing the quality since these modules are produced in a very controlled environment in a factory. This also reduces a lot of the wastage. So traditional construction industry processes results in about 30% of wastage, both material and labor. By having this productization approach, by producing products in factories, by reusing designs across projects, we are able to reduce this wastage significantly as well. One of the great challenges we have in the construction industry now is the shortage of skilled labor. So it's very challenging for many building projects to find the skilled labor contractors for on-site work. So with productization, we are able to move this labor requirement to more factories where labor can be more efficient. This way, we are also minimizing the number of laborers that are required on site. So we are addressing the skill labor challenge as well. So all of these benefits of productization leads to better quality designs, lower costs, lower project standard times. So the aim of productization is not to limit in any way the design. The productization approach allows us to take the artistic design that an architect will have. Architects like to have as much creativity as possible. And it really takes this artistic design and breaks it down into manufacturable modules. So modules that can be manufactured, that can be integrated. So it strikes the right balance between creativity and manufacturability. So it's not the productization approach is not about restricting creativity or standardizing all buildings so they all look the same, but it's about facilitating personalized production. It's about avoiding one-off projects with bespoke designs. It's about capturing and reusing knowledge and best practices across projects. So this allows us to increase the sustainability, reduce costs, reduce time across projects. Productization is an excellent way that leads to circularity. So productization approach reduces from a sustainability point of view, it reduces waste and carbon emissions through all the phases of the project, from design, construction, into operations. With productization, since we are breaking down the building into smaller interchangeable modules, we can think of a future scenario where we will be able to dismantle one module to perform upgrades to the building by replacing that with the newer modules, for example. We can also think of reusing the modules that have been dismantled into other buildings where these can be repurposed. So this approach fully supports the circular economy principles. So this approach, I think, will lead to a lot of satisfaction to both the city and the citizens, and fully meet their expectations for circularity and sustainability. So the building industry ecosystem is pretty fragmented. So there are a number of stakeholders who need to come together to work on a project of this magnitude. So we start off with the owners who will contract the architects who will do the initial concept design and create permit drawings and so on. We have obviously then the architects take the building product manufacturers, the product modules that have to be defined by the building product manufacturers, so such as bathrooms, stairs, slabs, and so on, and they have to incorporate that into the design. Then this design is handed off to the general contractor who has to work with the building product manufacturer, the fabricator, and the subcontractors to install this. So they become the prime integrators of the project during the construction phase. With our 3D Experience platform, we are able to connect all the stakeholders to make sure that they are working on the single model, the single project information during the planning, design, and construction phase. We always have access to the latest data in the project, so they are working on the single source of truth, and they are able to make the best decisions for the project going forward. So the 3D Experience platform is ideally suited for this type of scenario because we are able to connect all the stakeholders involved in a project, from owners, architects, general contractors, the building product manufacturers, and so on. It can also manage all the design data, or the multidisciplinary, the multi-trade design data, the multi-level of detailed design data, from concept design to detailed design to construction data. It can also manage the data across the life cycle of the project, from design, construction to operation. The 3D Experience platform is ideally suited for a productization approach like this. The virtual twins also allow us to validate the design, validate the construction, validate the behavior during operations for energy consumption, for example, at a very early stage. So the virtual twin is a very complete representation of the building. So not only the design information, but also the behavioral information and all the attributes and the process information that's needed to complete the building definition. So the 3D Experience platform and the virtual twin, I think, are ideal tools to support the productization approach. Productization is maybe revolutionary for the construction industry to some extent. It's transformational in nature, but the concepts of productization, such as modularity, the concepts of off-site manufacturing, these have been used in other industries like automotive, industrial equipment, aerospace for many, many years. So we are taking those principles, bringing them to the construction industry, which has not seen this transformation for several decades, and we are adapting it to the construction industry because there are some differences between the construction industry and manufacturing industry, where some work still needs to be done on site when the products have to be assembled on site and so on. So we have to adapt this this modularity and offsite manufacturing to the construction industry. And that's what we bring with the productization.